Hello and welcome to all students. In this lecture, we learn about matrices and linear transformation. We study row echelon form of a matrix. So let us see the outline of our today's lecture. First of all, we see some introductory part, then definition of echelon form of a matrix, and some examples based on echelon form of a matrix. In introduction, in linear algebra, a matrix is in echelon. In linear algebra, a matrix is in echelon form if it has the shape resulting from a Gaussian elimination. A matrix being in row echelon form means that Gaussian elimination has operated on the rows. A column echelon form means that Gaussian elimination has operated on the columns. In other words, a matrix is in column echelon form if its transpose is in row echelon form. Therefore, only row echelon forms are considered in the uh, remainder of this article. The similar properties of column echelon form are easily deduced by transposing all the matrices. Row echelon form of a matrix. Specifically, a matrix is in row echelon form if it satisfies following properties. First property is all zero rows must be at the bottom of matrix. In a non-zero row going from left to right, first non-zero entry must be 1. This 1 is called as leading one of that row. In two successive non-zero rows, the leading one in a row below must be at the right hand side of the leading one in row above. So these are the three if our matrix satisfies these three properties, then that matrix is called as in row echelon form. Note that these three conditions imply that all entries in a column below a leading one are 0. The following is an example of a 3 by 5 matrix in row echelon form which is not in reduced row echelon form. See below. Consider a matrix with first row A0, A1, A2, A3. Second row is 0, 0, 1, A4, A5, and third row is 0, 0, 0, 1, A6. Okay, so this matrix is in echelon form because it satisfies all these three conditions. In a non-zero row going from left to right, first non-zero entry is 1. In a two successive non-zero rows, the leading one in a row below appears at the right hand side of leading one in row above. Okay, so all these conditions are satisfied by this matrix. Therefore, this matrix is in row echelon form. Many properties of matrices may be easily deduced from their row echelon form, such as rank and the kernel. Transformation to row echelon form. So let us take one example to convert a given matrix into row echelon form. By means of a finite sequence of elementary row operations called Gaussian elimination, any matrix can be transformed to row echelon form. Since elementary row operations preserve the row space of the matrix, the row space of the row echelon form is the same as that of the original matrix. The resulting echelon form is not unique. Any matrix that is in echelon form can be put in an equivalent echelon form by adding a scalar multiple of a row to one of the above rows. For example, consider a matrix of order 2 by 3 with first row 1 3 minus 1 and second row 5 to 7. We convert this matrix into row echelon form by performing the row operation on it. So we observe that in first row is non-zero row, and going from left to right, first non-zero entry is 1, and that one is called as the leading one of that first row. So all entries below the leading one must be 0. Therefore, in the second row, at in the second row, the first entry 5 must be 0, and we make this entry 5 0 by performing row operation r2 minus 5 times r1. So to make the entry 5 0, we make use of the leading one in first row, and we perform the operation r2 minus 5 times r1. Then there will be change in only r2 row. First row is as it is 1. So something is wrong. So first row must be as it is 1 3 minus 1. Okay, and second row will be 0 and minus 13 and 12. And to make this minus, now the second row is non-zero row going from left to right. First non-zero entry is minus 13, and to make this minus 13 as 1, we divide to second row by minus 13, and we get minus 30. Okay, so in the third matrix, instead of minus 13, there must be a 1 plus 1. Okay, so last matrix, so second matrix must be like this: 1 3 minus 1. Second row is 0 minus 13 12. Third matrix must be like this: 1 3 minus 1 0 1, second row is 0, 1, 12 upon 13. Okay, let us take one example now. Reduce the following matrix into row echelon form. Reduce the following matrix into row echelon form. A equal to matrix of order 4 by 4, 3 5 1 3 1 3 3 5 1 3, first row. Second row is 1 3 5 1. Third row is 2 1 minus 1 1. Fourth row is 2 3 4 1. B matrix is again, it is the matrix of order 3 by 4. First row is 1 3 minus 1 2. Second row is 5 2 7 1. And third row is 1 3 minus 1 2. Third example, third matrix is C equal to, it is of order 2 by 3, 1 2 41, 6 1 3. And we reduce these matrices into row echelon form by performing row operations. Let us take first matrix. Matrix A is equal to 3 5 1 3 1 3 5 1 2 1 minus 1 1, and last row is 2 3 4 1. So now scan from top to bottom and consider a first non-zero row. So in the first non-zero row, going from left to right, first non-zero entry is 3, and we have to make this entry 3 as 1. So we make this 1 1 entry as 1 by performing this operation R12. That is interchange of first row and second row. So our next matrix must be 1 3 5 1 3 5 1 3, and remaining two rows are as it is. So just we have interchanged first row and second row. Now again scan from top to bottom. Consider first non-zero row going from left to right. First non-zero entry is 1, and that one is called as the leading one of first row. So all elements below that leading one must be 0. So as we are converting given matrix into row echelon form, therefore therefore all elements below the leading one must be 0. Therefore we have to make 3. So the elements in the leading below the leading one are 3 2 2. These elements we have to make 0. We perform row operations and we make this element 0. So if I perform to in the second row, see here, second row minus 3 times first row. So there will be change in second row. First row as it is 1 3 5 1. So for the second row, from second row we subtract 3 times first row. So 3 minus 1, 3 minus 1 is 0. Okay, next is 5 minus 9 is minus 4, and 1 minus 15 is minus 14, and last entry is 0. So now remaining rows as it is 2 1 minus 1 1, 2 3 4 1. Now we make the element 2 0 from the third row. Okay, so for that we perform the row operation R3 minus 2 times R1. So there will be change in R3 row only, remaining rows as it is. So first row as it is, second row as it is. So there will be change in third row only. So 2 minus 2 is 0. 1 minus 6 is minus 5. Then minus 1 minus 10 is minus 11, and and 1 minus 2. 1 minus 2 is minus 1. Now third row as it is 2, 3, 4, 1. Now again perform the operation for the fourth row, r4 minus 2 times r1. So all these operations we can perform simultaneously because they are independent. We can perform these operations simultaneously, no problem. So first three rows are as it is, so there will be changing only third row. So 2 minus 2 is 0, minus 3 minus 6 is minus 3, 3 minus 6 is minus 3, and minus 11, 4 minus 10 is minus 6, 1 minus 2, 1 minus 2 is minus 1. So now see here, so all elements below the leading one are 0. Now again scan from top to bottom. Consider the next non-zero row. Next non-zero row is 0 minus 4 minus 14, 0. So to make this element, to make the and again going from left to right, in the second row the first non-zero row is minus 4 and that minus 4 must be 1. So make that minus 4 as a plus 1. So how to make? We perform the operation. What is that operation? 1 minute. We perform operation r2 minus r3. R2 from the second row we subtract third row. So there will be change in second row only, third row remaining rows as it is. So first row as it is 1, 3, 5, 1. Now second row will be get changed. Okay, so r2 minus r3, see here 0, 1 minus 3, 1, and third row and fourth rows are as it is. Now in the second row there is a leading one and the all elements below that leading one must be 0. Therefore we perform the operation r3 plus 5 times r2. So there will be change in only third row, first two rows as it is, and r3 plus 5 times r2 is 0, 0, minus 26, 4, fourth row as it is. Now we perform this operation for the fourth row, r4 plus 3 times r2, 1, 3, 5, 1. There will be change in fourth row only, first three rows as it is, and fourth row will get changed like this, 0, 0, minus 15, 2. Okay, now again scan from top to bottom. Consider next non-zero row, means third row is a non-zero row. Going from left to right, first non-zero entry is minus 26 and that minus 26 entry must be 1. So we divide to the third row by minus 26 and the result will be, there will be change in third row only, first two rows as it is, and third row is 0, 0, 1 minus 2 upon 13, fourth row as it is. Now there is a leading one in third row. Now next non-zero row is fourth row. Going from left to right, first non-zero entry is minus 15 and make this entry 1 by performing the row operation r4 plus 15 times r3. So if I perform this row operation, there will be change in fourth row only, first three rows as it is, and the resultant row is 0, 0, 0, minus 4 upon 13. Okay, now again scan from top to bottom. Next non-zero row is the fourth row. going from left to right. First non-zero entry is minus 4 upon 13, and make this entry 1 by performing the row operation. Minus 13 upon 4 into fourth row, and the resultant matrix is here. So this matrix is in row echelon form. Okay, thus this matrix is in row echelon form. The row echelon form of a matrix is very much useful. We use it to find rank of a matrix, basis of row space of matrix, nullity of row space of a matrix, and to solve the system of linear equations. And rank of a matrix is nothing but the rank of a matrix is the total number of non-zero rows in its row echelon form. In the above example, matrix A has rank 4 because the total number of non-zero rows in the echelon form of a matrix A are 4. So let us take some examples for homework. Question number 1. Reduce the following matrices in the echelon form and hence find their ranks. So two matrices are given. So try to solve these two examples. Try to reduce these two examples into the echelon form of a matrix. And once we have a echelon form, you can write the rank of that matrix. The rank of matrix is nothing but just count the number of non-zero rows in that matrix. Okay, so for any problem, any query, you can contact. And for paying attention, thank you very much.